Something is changing beneath our feet. China has built a machine that doesn't just race across the land, it floats through it. A train that no longer acts like a train. It doesn't follow gravity's rules anymore. It's faster than passenger jets, quieter than a whisper, and built with the accuracy of a spacecraft. This isn't science fiction. This is the start of Earth's next transportation revolution, and China is leading it. Think about what happens when travel time between major cities drops to almost nothing. Economies merge. Job markets expand. The whole idea of distance starts to fade. This isn't just about moving people faster, it's about changing how civilization works. While most of the world argues about rail budgets and crumbling infrastructure, China is building something else entirely. Sleek, silent passages made of magnetic steel that can move millions of people at nearly supersonic speeds. Picture this. You step into a capsule, hear nothing but your breathing, and suddenly you're moving faster than a Boeing 737. That's not imagination, that's T-Flight maglev. China's jump into the vacuum age. The vision is bold. China wants to turn its massive geography from a problem into an advantage. In a country where major cities sit hundreds or thousands of kilometers apart, moving people and goods at extreme speeds isn't just nice. It changes everything economically. This train never touches its tracks. It levitates, gliding above the rail using magnetic force, so smooth that you could balance a coin standing up at 1,000 kilometers per hour. Think about that. A full-sized passenger train, moving faster than a jet, doing it silently and without burning any fuel. The secret? They removed the air. T-Flight doesn't fight, drag, or turbulence. It moves inside a near-vacuum tunnel, like a spacecraft gliding through orbit, except it's on Earth. In this environment with almost no friction, speed isn't just possible, it's unlimited. The technology uses powerful magnets that create strong magnetic fields. These suspend the train in mid-air while pushing it forward at the same time. No wheels grinding on rails, no air molecules slowing it down. The energy use becomes incredibly efficient. The train basically floats in a bubble of magnetic force, pushed forward by the same science that powers particle accelerators and MRI machines. A trip between Beijing and Shanghai takes almost 5 hours on today's fast trains. Soon it could take less than 2. That's not just progress, that's a complete shift. Think about what this means in real life. Business meetings that needed overnight stays become day trips. Families living far apart can have dinner together. Workers who could only find jobs in their region can now work anywhere in the country. The economic effects are huge. When Tokyo and Osaka are less than an hour apart, do they become one giant city? When Chinese megacities connect with trips under 2 hours, does the entire East Coast become one massive economic zone? These aren't just questions. Chinese engineers and city planners are figuring this out right now. Not long ago, China was known for copying Japan's Shinkansen technology and German engineering designs. But those days are over. The change has been careful and planned. Learn from the best, absorb their knowledge, then go beyond what they achieved. Meet the CR400AF, nicknamed the Fuxing, which means rejuvenation. This is China's first train designed completely in-house, every part from front to back. It's a statement that says, we don't copy anymore, we create. The Fuxing runs over 400 kilometers per hour, but speed isn't its only strength. Its real power is endurance. Unlike older trains that needed constant fixes and wore out after years, the Fuxing is built to last 30 years with barely any decline in performance. Every part, from wheels to electrical systems, is made to last. The train's design includes lessons from decades of high-speed rail use. Its computer systems constantly check the train's health, predict when parts need fixing, and adjust how it runs in real time. This isn't just a train, it's a smart machine that learns while it operates. Then came the CR380D, the ghost of the rails. At over 350 kilometers per hour, it doesn't roar or shake, it glides. Engineers designed its nose by studying swordfish skulls and how falcons cut through air. The result is a train that slices through air so cleanly you barely hear it coming. Stand near the track as it passes, and you'll feel a breeze, not a blast. This is more than just looking good. It's national pride built into steel and silence. The long nose isn't just for show. It stops air pressure from building up and creating sonic booms in tunnels, which matters a lot since much of China's high-speed network runs through mountains with lots of tunnels. Japan's Shinkansen E5 still represents perfection. It might not be the fastest at 320 kilometers per hour, but it's the most reliable. Japan's system is so exact that the average delay across the whole network is under 20 seconds per year. That's not transportation, that's art. The Japanese way focuses on reliability over pure speed. Every train leaves exactly on time, arrives exactly on time, and the whole system runs with almost supernatural punctuality. This isn't luck, it's the result of obsessive attention to detail. From track maintenance measured in millimeters to crew training that takes years. The cleaning crews preparing each train for its next trip have just 7 minutes to transform a 16-car train from used to spotless. They've perfected their movements so well it looks like a dance. This is Japanese engineering in action. Perfection through process. Reliability through routine. The L0 maglev is Japan's answer to China's T-flight, a train that floats 10 centimeters off the rail and races at 603 kilometers per hour. When it opens for regular service between Tokyo and Osaka, the trip will shrink from over 2 hours to barely 1. What's amazing is how stable it is. Even at 600 kilometers per hour, passengers feel nothing, no bumps, no sway. It's like floating in place. The powerful magnets create such a steady floating effect that passengers can stack coins, balance pencils, or work on laptops without any shaking. At speeds where normal trains would tear themselves apart, the L0 glides as smoothly as an elevator. The T-flight Hyperloop isn't just a train. It's a mix of aerospace and infrastructure. Instead of building more tracks, China is building vacuum corridors, huge sealed tubes where air pressure is so low that resistance vanishes. In these tubes, a floating train can move like a bullet through water without ever touching the sides. This is what Elon Musk talked about years ago. But while his prototypes still sit in test buildings, China has already built full-scale working sections. China's goal? A working commercial line connecting megacities at almost the speed of sound. The engineering problems are massive. Keeping vacuum pressure over hundreds of kilometers needs revolutionary materials and sealing methods. Emergency systems must work in near-vacuum conditions. Passenger pods must keep normal air pressure while traveling through near-space conditions. But China tackles these problems with total focus, treating each obstacle as something to solve rather than a reason to quit. Test tracks are running, and engineers improve designs every day based on real performance data. Germany's ICE-3, a name that means precision, hits 368 kilometers per hour during tests. Old trains put engines in one place. The ICE-3 spreads power across every car. Sensors constantly check the rails for tiny changes, adjusting wheel pressure in milliseconds. The result? A train that holds the track so well, it can take sharp turns that would derail others. This spread-out power system represents a new way of thinking about train design. By putting motors throughout the train instead of just at the front, the ICE-3 gets better weight balance, improved grip, and better backup systems. If one motor fails, the others pick up the slack instantly. Then, there's Italy's Italo AGV. Elegant, efficient, and completely electric. It swaps heavy engines for spread-out motors that save space and reduce weight. The cabin? Smooth as silk. At 360 kilometers per hour, the Italo shows Europe's focus on passenger experience. Its interior design rivals luxury planes, with careful attention to sound, lighting, and comfort. This is high-speed rail as a premium travel experience, not just fast transport. But if you want to see the real future of human transportation, look at Japan's Alpha X. It's the test bed for what trains will be like. in 2030. Yes, it actually changes shape to stay aerodynamic. The Alpha X's 22-meter nose isn't just for looks, it's built like a spear tip that can cut through wind without creating turbulence. Air brakes come out of the roof during emergency stops, and the whole train constantly adjusts its shape based on speed and conditions. This experimental train works as a rolling laboratory, testing technologies that will define the next generation of high-speed rail. Every trip creates massive amounts of data about air resistance, vibration, and passenger comfort. What China is building isn't just a faster train, it's momentum itself. Every kilometer of maglev track represents not just engineering skill, but vision. A refusal to believe that limits exist. While Western countries argue about budgets, China tests prototypes, improves magnets, and builds entire cities around its rail lines. It's not about one route. It's about a connected future. The country has promised to build over 150,000 kilometers of rail infrastructure, with thousands of kilometers for maglev and hyperloop technology. Think about a world where physical distance means nothing, where whole economies can work as if the planet shrunk overnight. That's not a dream. That's China's plan. The country is basically rewiring itself, creating a transportation network that will define how the 21st century moves. We're standing at the edge of a new era, one where sound barriers break and the ground becomes the new sky. When people in 2030 talk about travel, they won't choose between flight or train. They'll choose between different types of floating. Because when technology like this becomes real, the question changes from how fast we can go to how connected we can become. China has already built the prototype of that future, and the rest of us are still getting on our flights. So next time you hear a quiet hum on the horizon, don't look up. Look straight ahead. That's not a plane. That's the future, and it's moving faster than you think.